Hello everyone. So I want to give you an update to the Dynamic Data and Capabilities Working Group. And it went off for some reason. Okay, let's back up. So our focus in this second quarter was CRDTs. We made a lot of investment in the researching CRDTs. We actually made 2 requests for proposals, and there are 2 links there if you want to check it out and propose a solution for the problems that are there. Also, we get a lot of involvement with the research community, with some universities, some research centers as well. And also, we have researched a lot of topics around authentication and authorization as well. So, in brief, I will explain the current type of CRDTs and the problems they have. So, first of all, we have state-based CRDTs, which essentially replicate the whole state between replicas, and replicas exchange messages with the whole state, always. They guarantee strong eventual consistency, and they are reliably in the sense that the network might be flaky, but still things work out well. The drawback of this is obviously when the state is very large, it doesn't scale. So there's another type of CRDTs, which are operation-based. And essentially, operations are exchanged between replicas, and they are very thin, usually, because they just contain the operation that mutates the state. And they're usually smaller because of that, and take less bandwidth, of course. The drawbacks is that you have to have the entire set of operations or you must keep the entire set of operations for new peers. You have to deliver the whole set of operations always. And that brings us to a slow boot, because new peers don't have anything, so you have to pass always the entire set of operations in a single time. We are trying to solve that with compaction and garbage collection, but it's a very difficult problem to solve. And also, some operations must be delivered only once, so they are not really idempotent on some implementations. So we are exploring a new type of CRDTs, which we think will solve many of these problems, which is delta CRDTs. And essentially, the benefits is that replicas, when they are exchanging messages, they just exchange the difference between the states. And also, the updates afterwards are based in mutations, which are kind of similar to the operations on operation-based CRDTs. And this gives us the best of the both worlds in the sense that the state passed between replicas is small enough, and afterwards the operations are also small, and so we have the best of both worlds. So we made an implementation, actually Pedro Teixeira made an implementation of Delta CRDTs in JavaScript. It's on that repo over there. And it was highly based on the work done in this paper, Delta State Replicated Data Types, by Paulo Sergio Almeida, Ali Shoker, and Carlos Baquero. I think I pronounced that correctly. And these new CRDTs, Delta CRDTs, are being used as a dependency of an upcoming library on the PeerStar ecosystem, which is the PeerStar app library. And also, besides CRDTs, this library aims to have like an SDK for developers to build applications on top of that. And it will solve things like authentication, identification, collaborations over CRDTs, among other foundations that developers need. Also, we have invested in researching around JSON CRDTs by Gonçalo over there. And we made some research. There's a link on the research over there if you want to check it out. I'm going very quickly because there's a lot of stuff in here. And the second part of this talk is authentication. How can we reliably identify users in a peer-to-peer application? And how can we prove ownership over operations on CRDTs, right? This is a very difficult topic, but I think if we merge 3 foundations, which is DIDs, verifiable claims, and DID auth, we are able to accomplish that. And I will start by explaining roughly what is DIDs. DIDs are essentially identifiers that don't change, are immutable and persistent, and they are formed by a scheme, a method, and a method-specific identifier. I will just go on very quickly. A DID maps to or resolves to a DID document that contains, among other things, public keys, so that you can interact with the entities behind, like verifying signatures and encrypting connections. This is basically the motivation behind them. I'll skip it for now, but the keynote here is that they are a perfect fit to live in blockchains, right? In public distributed ledgers and essentially on blockchains as well. And then verifiable claims. Verifiable claims is essentially anything that you can attach to an identity. Even the name, your home address, and things like that can be a verifiable claim. And a verifiable claim usually is sent from an identity to another identity, but also you can have a subset in which the same identity can state or make statements about themselves. Like, I can prove ownership of my social account, like Facebook or Twitter, by generating proof of that, and that only depends on me. And because of that, we can, in an application, centralized application, we can do things like this, where we show user details pop over with the verifications on the social networks made in real time in a peer-to-peer compatible and friendly way. And the last topic is DID auth, which essentially is a ceremony where a party proves to a relying party that he owns and he controls the DID, right? And afterwards, and optionally, you can disclose verifiable claims so that the relying party knows your name, knows your social networks, and anything that you might want to disclose. So this is all cool, but is it usable today? Can we use them today? And are they accessible for regular internet users? That's the question here. I made a quick analysis over all the DID methods present in the registry. These are just the 4 most important ones. You might find additional information in that link. I will not elaborate on this. And all of this information is in a RFC, Identity and Authentication RFC in the peer-star repository. And as part of that RFC, we have made a proposal called the Identity Manager, which essentially is a wallet for your identities, a user interface, where you can create and import multiple DIDs, support multiple DIDs for your identities, which is useful because I have my own identity, but I can have one from Protocol Labs and so on, and manage that in that way. We can manage our claims and the social proofs and so on. We can authenticate to decentralized applications. And also, it should be intuitive and fluid for regular users. And because of the timing, is a great opportunity to become the de facto identity wallet for the web, and maybe later on for the native applications as well, on mobile phones and other devices. I have here some mock-ups, but you can see the complete set of mock-ups in the RFC as well. So what's next for the group, the working group? We are going to reach out projects such as Uport and Blockstack and explain the problems that we're having, and possibly work together to find a solution for those problems. We need to make a plan to integrate anything about identity and authentication on PeerStar app, which is a library I will be speaking tomorrow. And also, we should resume and continue the research on authorization and permissions as ACLs on top of these identity and authentication as well. And you may find the slides here. I have the full talk slides because I thought this talk was 30 minutes, so I have to check it out. But you can check the full slides over there. And that's all. Thank you. Anyone got questions?
Just that you missed the more important IP ID work that actually I did, which is the DID spec using IPFS. That actually plays well with Uport and Sovereign. So I'll do a lightning talk tomorrow on it.
That will be cool. Yeah, I know that that is actually the ID method implemented over there. But I think because of the delays of EPNS, it's kind of unusable right now. But we can talk tomorrow or. Yeah.